Hi everyone, we're going to find the domain, locate any intercepts, and graph f of x, and then find the range after we graph. So this is our piecewise function. It has three pieces, and we're going to test for continuity at x equals 0 by taking limits and also evaluate. So let's see, I think I forgot to write that down. But anyway, let's look at the domain. You can find the domain right away because this is your domain area here after the comma. So this is your domain. If you look at that, we're starting at -3, and then we're going all the way. We're reading the graph from left to right, going to infinity, because this is greater than 0, so that goes to infinity. All right, so let's go ahead and test for continuity. Here is the definition of continuity here, and it must follow, the definition is based off these three conditions. So basically, what's happening with this, we're testing at 0 because at 0 is where the graph is changing the function. So we have a linear, we have a constant, or this is going to be a point here, and a square root function. So we want to know if it's continuous when we graph this. So therefore our c equals 0. And so let's just see if our first condition works. So our c is 0, so what is f of 0? Well, we plug that into the middle portion. So everywhere where x is 0, that equals 3. So it does exist. We do have a value. And now we're going to test the limits. And we're going to do this part, which is the limit as x approaches c from the left of our function, and our c happens to be 0. Does it equal the limit as x approaches c, or 0, from the right of our function? So let's see what's going on. So we have 0 here, and we have a graph occurring on this side. When it is approaching 0 from the left, that means these numbers here, we want to know what's going on here. These numbers are less than 0. Now, approaching 0 from the right, so some graph in this area, that these numbers are greater than 0. So that's all we're going to do. We're going to plug in 0 to wherever this occurs. So where x is less than 0 is this first part. So you plug this 0 in. So when you plug that in, you get 3 plus 0 equals 3. Now, from the right, when it's coming from the right, these are all numbers that are greater than 0, which is this third part. So when you take the square root of 0, you get 0. And what we have is 3 equals 0, which is not true. So the left-hand side of the limit does not equal the right-hand side. Therefore, the limit does not exist and condition 2 fails. Once a condition fails, you don't need to move on. So this function is going to be discontinuous at 0. All right. So let's graph it. I'm going to go ahead and use my C part, my 0, and graph. This is our 0 right in here. At 0, it maps to 3. So we go up to 3, but it can't equal 3. So we do an open interval there. I'm graphing this one. All right. Now I'm going to go ahead and plug in -3. So here we go at -3. At -3, you plug that in, you get 3 plus a -3. That equals 0. So that, and it can equal it because you have an equal sign here. And we know this is linear, so we just draw a straight line. So we don't need to do all the points in between. Now at 0, that maps to 3. So at 0 here, it maps to 3 and it can equal it. So closed interval overrides open. So that closes that up. Now, so that's that piece. And the last piece is this one. So we still use the 0. At 0, it's 0, but it's open. All right, and then plug in 1. Square root of 1 is 1. Let's try 4. So this is 4. Wait, 3, 4. Square root of 4 is 2. That maps to 2. And 5, 6, 7, 8, 9, and you try 9. Square root of 9 is 3. That maps to 3. So there's that function. It keeps going on and on. All right, at 16, it's going to reach to 4 at some point. All right, so there's your function. Now, if you notice, this is why condition 2 failed. You can start drawing from -3 here, but then you have to jump down here to graph the second piece. So it's discontinuous. This is called a jump discontinuity. All right, it's a long word. All right, so therefore, that's why condition 2 failed. Now, let's find our domain, which we already did. You can write it as -3 to infinity, or you can just say, you can look at the graph here and say that x is greater than or equal to -3. Now let's look at the range. If you look at the range, that you're going to -infinity to infinity on the y, but we stop at 3, and we start at 0. Now it looks like it's open here, but we do have a point here. That's at your x-intercept, -3, 0. So we do have a 0 in the range. So we could just write it as y is in between, or let's just do interval notation first. So if we do interval notation first, it means we're starting at 0. It can equal 0, because we do have a value there at 0. And then we go to 3. Okay, and then it stops. Actually, it doesn't, because this goes on and on and on. So it really goes to infinity. So it goes to infinity on the y. So you can write this as y is greater than or equal to 0 if you want. Now for intercepts, we have our x-intercept that we already saw right here. We also have a y-intercept at 0, 3, which is right there. All right, and I think we got everything. And then the next thing we have to do is evaluate, and I forgot to put that down. I think it was f of -2, f of 0, and let's do f of 4. Let's just do f of 2. All right, so if you plug in -2, you're going to get 3 minus a -2. You have to use this first portion plus a -2, and that equals 1. If you plug in 0, we're back to this one, so that's where it equals 0. That equals 3. If you plug in 2, that's just going to be square root of 2, because we have to plug it into that one. All right, that's it. Thank you. Have a nice day. Bye-bye.